Hi everyone, welcome to my video. Today I'm going to talk about Linux Netfilter architecture that implements the packet filtering so we can use a firewall in order to protect our operating system. I'll be using UFW, a firewall front-end implemented, for example, on Ubuntu Linux, so you can learn how to use a simplified version of a firewall. Instead of using iptables or the new fs tables, we'll be using smaller, simpler commands to configure our firewall. Before we proceed, let me remind you, you can subscribe to my channel in order to support it and press the bell button so you can receive notifications about all the videos I'll be publishing. Now, let's do it. Not only system administrators know this, but also common sense in the computer's world tells us that firewalls are an important tool that can be configured to protect our servers, workstations, personal computers, and also network infrastructure. In the Linux ecosystem, iptables is a widely used firewall tool which interfaces with Kernel Netfilter packet filtering framework. For users and administrators who don't understand the architecture of these systems, creating reliable firewall policies can be a painful task, not only due to the challenging syntax, but also because of the number of interrelated parts present in the framework. There are 5 netfilter hooks that applications can interact with, and as packets go through the netfilter stack, they will trigger the kernel modules that have registered with these hooks. The hooks that a packet will trigger depends on whether the packet is incoming or outgoing, the packet's destination, and whether the packet was dropped or rejected at a previous point. This diagram shows the names of the 5 built-in chains that mirror the names of the netfilter hooks on netfilter, which are input, output, pre-routing, post-routing, and forward. If we create further chains with different tables, they will be registered within these hooks. The most common table is the filter, used to make decision about whether a packet can be passed through and continue, or to deny its request. The pre-routing hook is triggered when a packet just arrived and entered the stack. The input hook is triggered after a packet has been routed if it is to be delivered to the local system. The forward hook is triggered when a packet has been routed if it is to be delivered to a different host. The output hook is triggered after a local outbound packet enters the network stack. And the post-routing hook is triggered by any outgoing or forwarded network packets after routing is done and just before its transmission over the network. Now that I have already shown you netfilter's architecture, let me tell you that the most common application tool used to configure the firewall is iptables or the newest nftables. In this case, I will not show you how to deal and to create iptables syntax entries, but to use UFW frontend that simplifies all the process. I will show you all the main commands, some examples you can use for a typical workstation's firewall configuration, or even a server for its own protocols, group of ports, or special rules you might need to configure. So let's take care of that implementation. Okay, before we start, let me show you here a very interesting fact. I'm running a Linux, Ubuntu 2004, but in this video I'm running this virtualization using Parallels ARM, because the machine I'm using is a MacBook Air with Apple's M1 processor. So this Ubuntu Linux ARM version is running very smoothly. It's a very nice solution. Okay, let's start by showing you the status of my UFW. As you can see, it is inactive. So before we proceed, we need to enable it. Let's enable using UFW enable, and after the firewall is enabled, I can show you again the status. So you can see that the message is now active. Okay, let's activate the default configuration. UFW default deny incoming. So this will put our firewall with this default configuration. Now that we have changed the default configuration, we can proceed by creating new rules. As you can see, nothing changed in our status. To confirm you that our outbound connections are not being denied, I have just made a ping to Google DNS server, and now I will open, for example, a YouTube website, so you can see that it also works properly. Now let's close the web page and proceed. Now I will open a terminal in my host operating system to show you that I can communicate between these two operating systems. The main purpose of this first test is to show you that the ICMP protocol is enabled, because it is a default rule. So using this bridge network interface, I will ping my Ubuntu machine and show you that it works. So this is the IP I will be contacting. Let me ping 192.168.55.10, and I'm getting the response. I can show you that the traffic is showing correctly here. So this confirms that both machines have a link between them and can contact each other. So now let's proceed, showing you the status again. We still have our firewall in active mode. Now I will show you the main UFW files that we need to edit, configure in order to make our firewall run properly. This file that is located in the /etc/default folder has some default rules for our firewall. You can edit and adapt to your needs. Now let me enter another folder /etc/UFW, where you can find several files that we need to understand. In this case, the files have both IPv4 and IPv6 versions, and they are divided between the before rules and the after rules, because these two types of files are between the user rules. Okay, so we will be creating today user rules, but you can also edit and adapt to your needs other rules that are stated in this file, like the before.rules. So the test we have just made with ICMP is the one that was possible because of these rules. You can see there are default and stated in this file. Without them, we wouldn't be making the ping command properly. Now let's put here TCP dump with the port 80 filter, so I can show you that port 80 is blocked in my firewall. This is another example I want to show you. I have previously installed Apache 2 web server, and now I will create a new rule, UFW allow 80/TCP protocol. And now let me show you the status, and as you can see in my table, I already have a new rule for IPv4 and IPv6, and that with this rule I can now open my web page. Now if you want to check the table with numbers, you can do it with this command and delete rules by using UFW deletes. Let me delete both rules, IPv4 and IPv6, and as you can see, after these two comments, UFW delete one also, nothing will be left in my table. Now let's apply a new rule, now using the HTTP protocol name, because you can also use protocol names. And after I have implemented this new rule, you can see that I have the same in my table. Let me add another rule for HTTPS. Done. And in my status table, you can see I have both protocols, so both ports, standard ports for HTTP and HTTPS protocols. So use the numbers or the protocol names as you prefer. I am deleting the 443/TCP rules in this case. You can use this syntax with the delete and the rest of the rule. Now I'm allowing SSH protocol, so I can show you also that with port 22, the standard port, I'll be connecting remotely to my server. And this limit SSH command is very important, so you can limit the amount of connections that can be made simultaneously to avoid the brute force attacks, because it limits to a maximum of 6 connections in the last 30 seconds. Now let's make another rule. For example, a deny rule from IP 192.168.55.2. And as you can see, the rule is already in my table. So this rule will deny any connection from this IP address. Now a new rule, UFW allow from 192.168.55.2 to any port 22. In this case, I will show you how to make an exception, in this case to port 22, but it is important to notice that the order of the rules in the table is important, because they will be parsed by the firewall. So you need to take that in account, because the result could be different from what you would expect. Let me show you the status. As you can see, the reason why I could connect is because the port 22 in TCP protocol is allowed with the limit rule. Let me show you again that I can still connect to my remote machine using SSH. Now let's change the configuration again. I'm deleting rule number 3, the deny one, to make a different configuration in this case. I am deleting and creating a new deny rule, and then after that, let me show you what the result is. So using here the terminal again, as you can see, I put my password, I am already connected, and this confirms that the allow rule for port 22, the exception to the deny one, was doing nothing, because the first rule that allows connections from anywhere is the first to be evaluated by the firewall, and is guaranteeing the connection from this remote machine. Now let's change configuration again, because we really need to put a deny rule first and then open the firewall with the correct exceptions. In this case, I have already deleted rule number 2, the SSH allow, and now that let me create a new one, because now it will be positioned after the deny. So first the firewall denies, okay, and then it will allow for this exception. As you can see, because I am denying first, the packet is marked to be denied and the 22 TCP rule allowing that connection will have no effect. Okay, so the order of the rules is very important, and you need to think about it and test properly before doing anything. Now let me have the deny rule again, and in this case it will be put after the allow, and show you that I am already allowed to connect because I am allowing first and denying after that. Okay, so in this case the rule for port 22 will be properly positioned so I can connect from the remote machine to this one. Now let me reset all the rules and show you what happens. You will see that my UFW firewall is making a backup. Check the path of all the files that are being saved, and now as you can see the default state is inactive. Let me enable the firewall again, and after being enabled, let me show you that I can't connect because it is already blocked from its default state. I will allow it with a very simple rule for port 22 in TCP protocol, and if I try again, I am already connected. Okay, so starting from this point, let me proceed and show you that also port 80 is also blocked in the firewall's default state. No connection allowed, and then after I put the rule again, I can test with my browser and show you that it works properly. Now moving on, let me show you how we can make a rule to allow a port range instead of a single port. In this case, port 10,000 through 10,010 in TCP protocol. If I show you the status, the rule is already there. Another rule allowing, for example, a connection from my local network 192.168.3.0/24 mask to any port 443. So computers connected in this local network would be allowed to interact with my HTTPS web server. In this next rule, I am allowing any connection from Ethernet 1 network interface to my port 123, in this case for NTP service, for example, a different approach for a certain interface instead of a subnet. Here are the rules I have just made in my status. So after these examples, you can see that using the network interface, the computers that you want to connect or not, the protocols, the ports, you have a very nice interface with UFW and a very simple syntax to interact with your firewall. Okay, I hope you have enjoyed this video. Please comment below for any questions or suggestions you might have, and don't forget to press the like button and subscribe to the channel in order to support it, and press the alert button if you want to get notifications about all the videos I'll be publishing. Thanks again for watching, and I hope to see you on my next video. Bye bye guys!